In this example, we're going to go ahead and gather some information about this parabola, this quadratic function, put that information together and get a nice graph, as well as writing this in standard form, going from the general form that's given to us over here to standard form, which is given by this formula where we need A, H, and K. All right, so the first thing we're going to figure out on this is, does it open up or down? So in this case, what you need to do is you need to look at the value for A. Because this is in descending order, and it's a nice quadratic, that very first value we see out there, the leading coefficient, is a negative number. That tells us this opens down. All right, so parabolas that open down are going to have a highest point, a highest value there where our vertex is, and the end behavior, the tails, are going to go down. All right, next, our vertex. To find the vertex, what I like to do is use the formula h is given by negative b over 2a. We just say h is like the x value for the vertex, k is the y value. For whatever reason, we use h and k. So to help memorize this formula, I like to think about it as the very beginning of the quadratic formula and the very end of the quadratic formula. You just kind of lose the plus or minus and the square root business in the middle. All right, so in our case, we can say that b is given by positive 6, and we already identified a was negative 3. So this will be what? Negative of positive 6, or negative 6, over 2 times negative 3. I think we end up with negative 6 over negative 6, which will be 1. So 1 goes as our x value for the vertex. Now what we'd like to do is we'd like to find the y value. So k, what we can do is, I think the easiest way to go about this is just use the x value we already know and evaluate the original function at this x value. So plug 1 in for each of the x's in the original function. So this will be what? Negative 3 times 1 squared plus 6 times 1 plus 1. Or I think we're looking at negative 3 plus 6 plus 1 overall works out to be 4. So 1, 4 is going to be our vertex. Go ahead and put it on our graph over here on the right-hand side. It'll correspond with 1, 4. All right. The axis of symmetry is this nice vertical line that cuts right through the middle of our parabola, and it'll be a mirror image on either side, on the left and right-hand side of that vertical line. Because this is a vertical line, it's always going to be x equals some value, and because we know it goes right through the middle where that vertex is, it has to be x equals 1 in our case, because that's the x value from our vertex. All right, next up, let's go ahead and find the y-intercept. The y-intercept always occurs whenever our x value equals 0. So what we can do is go ahead and say, we have an x value, we have a function, let's evaluate our function again at that x value. So f of 0 is going to be negative 3 times 0 squared plus 6 times 0 plus 1. And when you're given these general forms for a quadratic function, the ax squared plus bx plus c, this always works out that the y-intercept is going to be the value for c at the end there. Because 0 plus c is always going to be c. All right, so we have 1 as being our y-intercept, right about there. Finally, let's do standard form next and then finish up with x-intercepts. I think it's a little easier that way, but you may think differently. All right, so standard form shouldn't be too bad. What we need to do is we need to kind of plug in the different values we've already found, right? A is going to be negative 3. Same A as the original. H we identified as being 1. And K we identified as being 4. All right, so now that we have our standard form written out there, what we can do is I like to use it to find my x-intercepts. You can do this different ways, but I like to do it this way. So x-intercepts always occur whenever y equals 0, or we could say f of x equals 0. And I'm going to take that value 0 and plug it in for f of x over in that standard form. So 0 replaces the left-hand side, is going to equal negative 3 times quantity x minus 1 squared plus 4. And why I like to do it this way is I'm going to make this into a power equation if at all possible. So from here, what I'm going to do is try to isolate that part that's squared on one side all by itself. So to do so, I'm going to go ahead and subtract the 4, move it to the other side. So 0 minus 4 makes negative 4, is negative 3 times the quantity x minus 1 squared. Next, let's still try to isolate that part that's squared, the parentheses. So I'm going to get rid of the negative 3 by dividing both sides by negative 3 next. Negative over a negative makes a positive on the left-hand side. From here, we've created a nice power equation where one side is raised to an exponent, and we have a constant on the other side. So let's next go ahead and apply a square root to both sides. That'll counteract the square on the right-hand side. And because we applied a square root to both sides, let's also make sure we include a plus and minus. That's what we typically do to do the absolute value business. All right, from here, we still have x minus 1 on the right-hand side. We have plus or minus the square root of 4/3 on the left-hand side. We'll add 1, and we'll have solved for x. And that plus 1 is not underneath the square root, of course. All right, let's go ahead and get an approximation going for this one. So we have x is going to be positive square root of 4/3 plus 1. And we're going to have x equals the negative case, the negative square root of 4/3 plus 1. All right. And maybe getting the calculator out to help here. Square root of 4/3 works out to be about 1.1547. So when we add 1 to that, we get 2.1547, just a little bit bigger than 2. And then the negative 1.1547 plus 1 makes this about negative 0.1547. All right, so on a graph, we have just a little bit to the left of 0 and a little bit to the right of 2, but really, really close to both those values. All right, to finish up this graph, let's go ahead and start at our vertex. And we're going to come down, hit our y-intercept, hit our x-intercept, and we're going to mirror that on the right-hand side as well. All right, it should look like a mirror image on either side of that axis of symmetry. So I hope this helps out as you go ahead and are working on graphing quadratic functions and gathering all this information to go along with them. Good luck.